tell me, how was your exam? How was IISc? How many of you wrote it? No one? Okay, fine. So let's start with 2D then. First, let's start with 2D geometry, then we will go to vectors, and then we will go to 3D geometry. Okay? Alright. So we start with our first question, and I have mostly selected nest multiple select questions, so that okay, they're equivalent to 4 questions if MCQ. Okay. So this one is from nest 18, question number 54. This is based on multiple concepts, but all of them are from 2D geometry only. For every a in the set of real numbers, let PA be the parabola given by y equal to x squared plus 2ax plus a. Then, option A, there is a common point which lies on PA for each a. There is no common point which lies on PA for each a. So, options A and B are mutually exclusive if you see. Correct? Both of them cannot be right. And also at least one of them must be right. Option A says there is a common point for all a. Option B says there is no common point for all a. Right? Okay. See, the vertex of the parabola PA lies on the line x equal to negative a. That's the vertical line. And D, the locus of the vertex of parabola PA is a parabola whose vertex is negative 1 upon 2 comma 1 upon 4. Now for C and D we have to deal with them independently. Let us start with options A and B. Okay. Now what is the essence when they say that there is a common point? The common point is an indicator that all of the parabolae, they pass through the same point, right? All members pass through same point. Okay, and interestingly, if they pass through the same point, we must be able to find its coordinates. Okay, and the coordinates should not be dependent on a if a is right. Okay, that is a point independent of a. Is that clear? If they are saying there is a common point, that common point's coordinates must be independent of the value of a. Have you understood that point? As in, see, we don't know whether it is right or wrong. Okay, we are just saying, extending what option A is telling us. Okay, so what we can do is, we'll say let A and B be real numbers. Okay, now if at all these two parabolae they intersect at the same point, well, they will intersect somewhere, we must say x squared plus 2ax plus a equal to x squared plus 2bx plus b. Correct? Now we can get rid of x squared. Okay, then we let's bring 2bx here. So 2 common, a minus b into x, a there. So x is equal to negative of a minus b upon 2 times a minus b, so negative 1 upon 2. Okay, which means at least the x coordinate of the point where the all of the parabolae meet, that is independent of a. Now how about its y coordinate? Can we find the y coordinate too? The answer is yes. Substitute x as negative 1 upon 2. So negative 1 upon 2 squared would be 1 upon 4. plus 2 times a into negative 1 upon 2 plus a. Now this also gives us a number which does not depend on a. Okay, 2 gets cancelled, so it's negative a plus positive a. So what can we say about option A? Is option A correct? There is a common point which lies on PA for each A. The answer is yes, it's true. And what is the common point? The common point has x coordinate negative 1 upon 2 and y coordinate 1 upon 4. Raise your hands if you have understood this. Great. So automatically B is ruled out. Okay, automatically B is ruled out. Acha. Now option C and D, although are not exclusive, okay, both of them are concerned with the vertex of the parabola. Okay, vertex of the parabola. So let's now focus on option C. Okay, let's now focus on option C, and to find to decide whether it is right or wrong, okay, we need to express the equation of the parabola in such a form that we can determine its vertex. Okay, now the vertex can also be determined the calculus way, right, because that's the minimum in this case, isn't it? So see, this parabola y equal to x squared, it must be of this form, right? It must be of this form. So which method do you prefer? There are two ways: completing the square or you can also do it by calculus, that is finding derivatives. Tell me, which way should we go? Calculus will be better. Okay, let's go to dy by dx. So 2x plus 2a. Okay, and dy by dx is 0 at the minimum, so or at the vertex, so x is equal to negative. Okay, x is equal to negative. So wherever that parabola is, okay, wherever that parabola is, this point must be having its x coordinate negative. Please raise your hands if you understand that. See, this is not y-axis, by the way. The green line that I have drawn is not y-axis. Okay, it will be y-axis only when a is equal to 0. Okay? Fine. So this is x equal to negative a. Can we find y? Yes, y can be found out. A squared minus 2a squared plus a. So it is negative a squared plus a, or a minus a squared. Okay, so we have successfully determined both x as well as the y coordinates of the vertex, isn't it? X coordinate is negative a, y coordinate is a minus a squared, y coordinate is a minus a squared. Let's go to option C, which says the vertex of the parabola PA lies on the line x equal to negative a. Option C is correct. Okay, option A correct, B incorrect, and C correct. Okay, we can also do it by completing the square. Okay, so for that you are required to add a squared on both sides and then shift a there, but you basically will get the same result. Okay, acha. Now let's go to D. Okay, let's go to D. So although as we said earlier, D is not directly the complement of C, but they indeed are related to each other, because now they are asking us to find the locus of the vertex of the parabola. Okay, now we know the vertex already. X is negative a and y is a minus a squared. So is it possible to find out the relationship between the x coordinate of the vertex and y coordinate of the vertex? Yes. How to find it? X is negative a, y is a minus a squared. So I can say that yv is equal to negative of xv minus xv squared. Have you understood this?
Yes.
Yes. So now how is the situation? Y is equal to negative x minus x squared. Okay, negative x minus x squared, and yeah, okay, so let's continue now. We have found out the locus now. Okay, oh sorry, we have found out the equation of the locus. All we need to do is find out its vertex. Dy by dx is equal to minus 1 plus 2x, sorry, minus 1 minus 2x must be equated to 0. So x must be equal to negative 1 upon 2, y must be equal to 1 upon 2 minus 1 upon 4 or 1 upon 4. So is option D correct? Yes, option D is correct. Okay, option D is correct. Alright, so option A is correct, option C is correct, and option D is also correct. Now let us go to GeoGebra and see whether all these parabolae they indeed pass through the point or have their common point as minus 1 upon 2, 1 upon 4. Okay, let's do that. So for that I need to first plot the point. Okay, oh sorry, this is GeoGebra, sorry. Yeah, minus 1 by 2 comma 1 by 4. Okay, that is our point A. And now let's go to y equal to x squared plus 2ax plus a. Y is equal to x squared plus 2ax plus a. ठीक है. Now what we will do is we will let a change. Okay, we will let a change and we'll see whether whether the parabola passes through that point. Okay, yes. So what do you see? You see that we are changing the value of a, but the parabola kind of happens to be ruling on the point. Correct? So that result is right. And similarly we can build on that. Okay, we can build on that the vertex. Okay, so for the vertex we just need to plot x equal to minus a and see whether the u junction is there. It's true now. Okay, the u junction is there, the line, and the line and the parabola they intersect at whichever point that is x equal to minus a. Okay, that is x equal to minus a. Alright, so that's it for this particular question. Initially, well, when I looked at this problem for the first time, I used the completing the square approach. Okay, I used the completing the square approach where you have to basically shift the origin and express it in the form x squared is equal to 4by, if in case you people are interested in trying that way out, but otherwise you can definitely go for the calculus method. And of course, because the coefficient of x squared is independent of a, you are guaranteed that the parabola will always be directed like this. Okay, fine. Any doubts in this question? No? Okay. Now let us go to question number 2. This is from NEST 2022. Second shift, question number 45. Consider the set of lines in the plane at a unit distance from the origin and intersecting both x and y axes. Let S be the set of midpoints of segments of these lines joining their point of intersection with the x and the y axis. Then S is 1 upon x squared plus 1 upon y squared equals 4, 1 upon x squared minus 1 upon y squared equals 4, x squared plus y squared equals 4, y squared equals 4ax. Now look, what could be the set of lines in the plane at a unit distance from the origin? In the plane, unit distance. This basically is family of lines, or rather let me put it now in this way, family of tangents to standard unit circle. Why standard unit circle? Okay, because from origin is what they want. From origin, that means if we place our center of the circle at the origin, it will become a standard circle. Secondly, they are saying at a unit distance. Okay, they are saying unit distance. Unit distance means radius of the circle must be equal to 1. Raise your hands if you have understood that. Everyone? Okay. Now, if we imagine the collection of all tangents to unit circles, okay, let's say this is our circle, y, x, I'm only showing one tangent as demonstration. Okay. Fine. So let the points be A and B here, the intersection points. And we want to find out the midpoint of AB and its locus. Okay. Now look, what is the equation of tangent for a unit circle? See, it is x1 plus y1 equals 1 for a unit circle. We know that because radius is 1. But I am recommending you to use the polar coordinates here. Now what is the benefit of that? Because we know x1, y1 also lie on the circle, okay, and also on the tangent. So if you happen to do that, you will say x cos theta plus y sin theta equals 1. Correct? And what will be theta? Theta will be basically the angle which that point is making with the x-axis, standard polar coordinate. Okay. Now, where will this line or where will this point intersect x-axis when y is 0? So what will be A? A will be sec theta comma 0. And what will be B? B will be cosec theta, well, 0 comma cosec theta, because it is intersection with y-axis. Any doubt in this? When this becomes 0, when y is 0 for x-axis intersection, x will be 1 upon cos theta, which will be sec theta. Is that clear? Yes?
Yes, sir.
Okay. Now, आगे का तो आसान है. What we need to do is, we need to look for a relationship between sec and cosec. कैसे करेंगे? Cos squared theta plus sin squared theta equals 1. But cos is reciprocal of sec, so this will be 1 upon sec squared plus 1 upon cosec squared equals, oh wait, उनका midpoint चाहिए ना, sorry, just a moment. Midpoint is what we need. Midpoint will be sec theta by 2 and cosec theta by 2. Sorry, my bad. Yeah, okay, my bad. So now I think 4 will come there. Yes, okay. So let's say y coordinate of m is 1 upon 2 sin theta. ठीक है? And x coordinate of m is 1 upon 2 cos theta. So sin squared theta plus cos squared theta would be 1 upon 4y squared plus 1 upon, so we are now shifting cos theta to LHS and bringing xm on the RHS, okay, plus 4x squared equals 1 Yes, yes. So we were missing that 4 because we had not considered that m was the midpoint. Okay. So 1 upon x squared plus 1 upon y squared equals 4. Do we have that option? The option is A. Is it clear?
Yes, sir.
So again, you please note that this is a straightforward question, I would say. But just to begin with, just to solve this question, we have to first understand what could that set of lines be. And that is family of tangents to unit standard unit circle. एक बार वो आ गया तो फिर आगे का आ जाएगा. ठीक है? Now let's see what the curve A looks like. 1 upon x squared plus 1 upon y squared equals 4. Let's see. Okay, let's see. Not comment anything here. As far as the shape is concerned, I think it is bounded. Yeah, see, the values can never be 0 for obvious reasons. Yeah, so x equal to 1 upon 2 or x squared equal to 1 upon 4 and also y squared equal to 1 upon 4, they will be asymptotes to this curve. Okay, so the curve's values will not exist, rather do not exist when x coordinate is in between minus 1 upon 2 and plus 1 upon 2. Right. There or same thing applies to y. Okay. All right.
What would have been the issue if we had used xx1 plus yy1 is equal to 1?
No issues. All you have to do is this. Had you not used that, after all, we are eventually coming back to cos squared theta plus sin squared theta equal to 1, isn't it? So even if we did not, even if we had not used cos theta and sin theta, at the end what we have basically made use of here, sin squared theta plus cos squared theta equals 1, correct? So and x1 is cos theta and y1 is sin theta. Now the benefit of using cos theta and sin theta instead of x1 y1 is you immediately realize that we have to use the identity and we can proceed. Using x1 square plus y1 square equal to 1 will also give you the same answer. Okay. Alright. Any other issues with the problem? Yes?
No, sir.
No? ठीक. Okay, question 3. This is also a multiple select question. This is from NEST 2023 first shift. Let A and B be 2 points on the parabola y minus 2x squared equal to 0 and O be the origin 0, 0. If OAB is an isosceles triangle, then the y coordinates of A and B are equal. OAB is an equilateral triangle, then length of each side is root 3. OAB is an isosceles triangle and the two equal sides are of length root 3. Then OAB is an equilateral triangle. OAB is an equilateral triangle, then its altitude is root 3. Acha. So there are 2 points on this parabola. The equation of the parabola is y equals 2x square. Even powers of x, so it must be symmetric about y-axis. So how would the curve look? The curve would look like this. Okay, the curve would look like this. This is origin. Now here is a trick about this problem which you need to realize. No, not saying need to know. Look, usually when we think of an isosceles triangle, okay, the image that we have in our head is two sides equal, and that's true, and we are naturally tempted to mark or to imagine a situation like this. Okay, to imagine a situation like this, and there is nothing wrong here. Okay, if this is my point A and if this is my point B, then it's true that y coordinate of A and y coordinate of B, they both are same. So you are bound to, well, you are likely to mark option A as the correct option, but here is the thing that we are missing out, and that missing out thing is, it's not always the case that O has to be the point of intersection of the equal length sides. Meaning, I can also select, okay, I can also select OB, I can also select OB, and then what can I do? I will draw a circle centered at B and radius equal to distance OB, okay, radius equal to distance OB, and then I can consider this point, let me call it A prime, okay, let me call it A prime, and now if I join A prime B, okay, if I join A prime B and A prime O, is OA prime B an isosceles triangle? Yes, no,
Yes.
it is an isosceles triangle.
Yes.
आइसोसेलेस हो गया वो, लेकिन उसका y कोऑर्डिनेट्स a और b का सेम है क्या? नो, y coordinate of a dash is not equal to y coordinate of b. That means there are two possibilities: either the y coordinates will be equal or the y coordinates will not be equal. But if you are marking option A, you are saying there is no exception to that, but here we have found out an exception. So can option A be correct? No, option A cannot. Have you understood this?
Yes, sir.
हाँ, मतलब हो सकता है, नहीं भी हो सकता है. Okay, option A. Go to B now. Triangle OAB is an equilateral triangle, then the length of each side is √3. Okay, length of each side is √3. Now how to handle this situation? Okay, acha, wait. What can you say about option C considering the state of option A? OAB is an isosceles triangle and the two equal sides are of length √3. Then OAB is an equilateral triangle. See, right here we can rule out that possibility. Meaning, if we say that OB is √3 and at the same time we say BA prime is √3, there is no chance that OA dash will be equal to √3. Is that correct? So can it be an equilateral triangle if it is isosceles and two equal sides are of length √3? No. So C is also not right. Please raise your hands if you understand that. We have just carried our discussion on option A to C. Okay, we said in option A we did not put any restriction on the value of OB, but now we are, because they are saying OAB isosceles है, दो sides equal है तो equilateral ही होगा, but not necessarily. OA dash B is a triangle which is isosceles and has its sides √3, two sides, but the third side will not be that. ठीक है? अच्छा, now we will come to option B and option D also. ठीक है? So if it is an equilateral triangle, then in option B they are saying length √3 है, option D में कह रहे हैं altitude √3 है. So also these two options are complementary. Okay, if one is right, the other one will become wrong. Okay, so how to now check for that? It's easy. Let me draw another figure here. ठीक है? Let me draw another figure. ठीक है? So now to make it look isosceles, or sorry, equilateral, see, now this angle should be 60. Look at the center of the screen, top center. Okay, it should be 60, but now let me take it here. We'll assume that it is the equilateral triangle. ठीक है? OAB. अच्छा, Now look, this is 60. ठीक है. OB is how much? अच्छा, we have to find that. Okay, we have to find that. Let us call OB as alpha. ठीक है. Let's call OB as alpha. Now, if OB is alpha, then what will be the x coordinate of B? Will it not be alpha by 2? And what will be y coordinate? Root 3 alpha by 2. Correct? Use polar coordinates. समझ में आया क्या ये? OB is like that length, है ना? तो उसका जो projection है x axis पे, that will be x coordinates, so cos, and the other one will be. Okay. Now we would like to see.
Sir, we could have also found it by using intersection of this straight line and parabola.
हाँ, वो भी निकाल सकते हैं. वही हो गया ना, y equal to root.
Yes.
वही हो गया, y equal to root 3x.
Yes.
हाँ, that's what I'm saying. एग्जाम में कोई एक अप्रोच ही नहीं आएगा दिमाग में. मतलब हर एक सी फॉर एवरी स्टूडेंट द अप्रोच विल बी डिफरेंट. ठीक है. या बट दैट्स ऑल्सो गुड. अच्छा, अभी हमको अल्फा की वैल्यू इससे निकालनी है ना. y इक्वल टू 2x स्क्वायर. So 3 alpha squared, sorry, not okay, don't square. Root 3 alpha by 2 is equal to 2 into alpha squared by 4. Okay, 2 into 2, 4. So this gets cancelled, alpha gets cancelled, and we know alpha is not equal to 0, so alpha is root 3. Okay, so side of the equilateral triangle has indeed turned out to be root 3, so option B is correct and option D is not. Because if an equilateral triangle has its side equal to root 3, then its altitude must be less than root 3. है ना? So B is correct, D is not correct. Now see, you might say only one of the options was correct. How is it a multiple select question? See, in multiple select question, there is no guarantee that at least 2 will be right. So if you open this 23 PDF, shift 1, you will find that this question actually carries more marks than MCQs because it is included under the category of multiple select questions. And therefore, we had to look for A, B, C and D. Had it been a multiple choice question, from A and C we would have directly gone to B. Well, in fact, we have done that the same way. पहले A को reject किया, फिर C को किया, फिर B को गए. ठीक है? Okay. Any doubt in question 3? Okay, everybody is clear with question 3, right? Okay. Achha, now there are a few more questions which are there in this sheet. I will leave them to you. For the students who have been here for the IISc aptitude test course, we have already solved these problems, so I don't intend to solve or resolve them again. For those who have joined specifically for this next sessions, I will encourage you to solve these questions and send me the solutions. I will, while uploading the sheet, I will make sure that I'll paste the solution of these questions here. Okay, both these questions are from Nest 23 only. Okay, question 4 is there, and then this question 5 is also there. Okay. Yes. So in question 5, I remember when we solved it, my method was lengthier. I think Anaga was there and she told me just, or Kaushiki I think, just subtract and get the answer. Okay, so you can try question 5. This is multiple choice question and this is also a multiple choice question. ठीक है, तो ये होमवर्क के लिए ट्राई करो, आएंगे, ज़्यादा मुश्किल है नहीं. ठीक है. Fine. Now we will go to vectors. Okay. Now before we go to these MCQs on vectors, let me tell you that whatever papers that we have, most of the recent nest vectors PYQs are multiple select questions. So write in one question, they can check for your understanding of collinear vectors, coplanar vectors, dot product, cross product, angle between vectors, magnitude, inequalities associated with magnitudes, everything. Okay. So I've done the same thing. Okay, I've selected those questions which are multiple select questions. Okay, I think only one of them is multiple choice. Let's see. Question 1. Let A bar and B bar be non-zero vectors. Non-zero vectors. Let S be the set of vectors V bar such that A bar cross V bar is equal to B bar. Then there exists a positive real number R such that magnitude of V bar. So this is a notation from linear algebra. So they call this notation as norm of V bar, but for us this norm will actually be equal to the magnitude itself. Okay, please note that. So there exists a positive real number R such that the magnitude of V bar is less than R for all V bar in that set S. S is non-empty if and only if A bar dot B bar is 0. S is contained in a plane. If V bar and V1 bar and V2 bar are in S, then there exists a scalar lambda such that V1 bar minus V2 bar is equal to lambda A bar. Okay. Now let's try to write down the equation and see if we can make some sense out of it. A bar cross V bar is equal to B bar. Use properties of cross product. We immediately arrive at the conclusion that A bar must be perpendicular to B bar and V bar must also be perpendicular to B bar. Please raise your hands if you understand this. Okay, A bar is perpendicular to B bar and V bar is perpendicular to B bar. And what is the second conclusion that we can draw? Magnitude of A bar, magnitude of V bar into sine of the angle between them, okay, which can be from 0 to 180 degrees, equal to magnitude of V bar. Option A is concerned with the magnitude of V bar. So let's go to magnitude of V bar, which according to their notation is norm V bar. Okay. So what will that be? Magnitude of B bar upon magnitude of A bar into, well, I will not use that, into cosec theta. Now, what can be said about option A, considering that we have got cosec theta here on the right side? We know, what do we know? We know that as theta tends to 0 from right, okay, or let's say as theta tends to pi from left, what happens to cosec theta?
Approaches infinity.
Yes, approaches infinity. वो 0 हो जाएगा sin theta, मतलब 0 के पास चला जाएगा तो cosec theta infinity होगा. And we have deliberately written these things here, 0 plus and pi minus. ठीक है, cosec theta tends to infinity. So can we say that magnitudes of the vector V bar will be bounded? No. Right? See, this will not always happen when theta tends to 0 plus or theta tends to minus. But nonetheless, we have ruled out option A. Have you understood this or not? If you haven't, let me know. I will explain it again.
Understood, sir.
Others? Okay.
Yes, sir.
ठीक. Go to B now. is non-empty if and only if a bar dot b bar is 0. This is a biconditional statement, if and only if. So we have to prove two things here. If S is non-empty, then a bar dot b bar is 0. And if a bar dot b bar is 0, then S is non-empty. So how to prove that? To prove the second statement, let us start with a bar dot b bar equal to 0, and none of them is a null vector, so a bar is perpendicular to b bar. So we can definitely express b bar as a bar cross some vector b bar. Is that clear? According to the magnitude of b bar and a bar, we can decide or adjust magnitude of v bar and sine theta. Is that clear or not clear?
Yes.
Okay, so this if part is clear. Now let's go to only if part. S is non-empty. S is non-empty. That means there exists v bar in R3. Okay, there exists, okay, assuming that it's a three-dimensional thing, okay, there exists v bar in R3 such that a bar cross v bar is equal to b bar. Therefore, a bar is perpendicular to b bar by the definition of cross product. Therefore, a bar dot b bar is 0. So the only if part is also proved. Okay. Remember, in biconditional, when you see if and only if, दोनों तरफ से prove करना है. Assuming this, check for this. Assuming this, check for this. Okay. And if both of them turn out to be true, only then whatever statement you have made, biconditional statement, that will be considered as true. ठीक है? So option B is correct. Option B is correct. Now let us go to option C. Okay, let us go to option C. S is contained in a plane. Is that true? Let's see. Again, we have to write down this equation, and we are looking for V bar. Okay, we are looking for V bar. Property of cross product will again come to our rescue. Okay, A bar perpendicular to B bar, V bar perpendicular to B bar. Okay, now what does this mean? This basically means B bar is perpendicular to plane spanned by A bar and B bar. Okay, now see what is meant by plane spanned by. By spanned by we mean if I take any linear combination. Okay, if I take any linear combination of this, I will get any vector, okay, in the plane of, okay, I'll get any vector in the plane of A bar and B bar. Okay, now look here, this is true because if I take A bar as I cap, the only requirement is that they shouldn't be collinear. If I take B bar as J cap, then we can get any vector in 2D, we know that, x I cap plus yj. Okay, any vector in the plane. है ना, get any vector in the plane. So B bar is perpendicular to plane spanned by A bar and B bar, and combining with the fact that B bar is perpendicular to B bar and it lies in a plane with A bar, we can say that C is also right. Okay, S is contained in a plane. Now if you are still not convinced that how can it be in a plane, it can also have other possibilities, let us think about it in this way. Okay, see, let's think about it in this way. Okay, so let's try to argue using the, say, the counter way. Okay, also known as reductio ad absurdum. That means whichever result we want to prove, we consider its negation and prove for negation. Okay, if the negation turns out to be true, result is false. If the negation turns out to be false, then the result is true. Okay, or contradiction, method by contradiction. Okay, let's see if we can prove it this way. S is contained in a plane, so we'll say S is not contained in a plane. Okay, so suppose this is the plane of A bar. Okay, suppose this is the plane of A bar which is perpendicular to B bar. Now look here, there are many planes which pass through. Okay, there will be many planes which pass through A bar, but we have to select only one which is perpendicular to this. Okay, let me add it here. There are infinitely many planes. Okay, there are infinitely many planes through A bar, but we consider only one of them normal to B bar. Do you agree with this claim? There are infinitely many planes, but the moment you rotate it a bit, the angle between that vector and B bar will no longer be 90 degrees. Is that clear?
Yes.
Yes.
Okay. Now let us suppose that V bar, okay, V bar is isn't in the black plane. Okay, let us suppose V bar does not belong to black plane. Okay, suppose V bar does not belong to black plane. Now the moment you say this, something interesting turns out. Now if V bar is not perpendicular, suppose V bar does not belong to black plane. Okay, suppose V bar does not belong to black plane, it must have a non-zero projection on B bar. Is that clear? अगर इसको V bar लिया और क्योंकि वो प्लेन में नहीं है, उसका एक कंपोनेंट, एक प्रोजेक्शन उसका B bar पे होगा जो नॉन ज़ीरो होगा. प्लीज़ रेज योर हैंड्स इफ यू अग्री टू दिस. Now if it has a non-zero projection on B bar, then theta, or let's say the angle between V bar and B bar, will not be 90 degrees. है ना? अगर उसका प्रोजेक्शन है मतलब cos theta zero नहीं है, because magnitudes cannot be zero. Okay, so if the projection is zero, it has to be because of the angle. But V bar perpendicular B bar given. It's given here. Okay, also it's given here. It is given here. Okay, so it contradicts with what we said, therefore option C is right. मतलब ऑप्शन में जो दिया था उसका निगेशन गलत है, मतलब जो ऑप्शन में दिया है वो सही. Okay, therefore C is correct. S is contained in the plane. Now see, they don't say S is entirely in the plane or S spans the plane. It cannot, because V bar cannot be collinear with A bar. Okay, V bar cannot be collinear with A bar, because if it is collinear with A bar, then their cross product will become 0. Okay, so it contains all the vectors V bar or all the vectors in that plane which are not collinear with A bar. Okay, acha. Now let's go to option D. I think this is simple actually. Option D is simple. Let's check it here. Do you people want to try this? Okay, let's see how it can be done. Tell me. They are saying if V1 bar and V2 bar are in S, then there exists lambda such that V1 bar minus V2 bar is equal to lambda bar. How to do it? Let us first write down this. Tell me what can be done. We want this. Yes, Anava.
So, this is basically the condition of co-planarity,
Which one?
and since because V1 minus V2 is lambda A, this is basically the condition for coplanarity
Of which
So-
vectors?
V1, V2 and A.
Correct. Yeah.
So, and we have already proved that these vectors will be coplanar, so this option will be correct.
Yes. Well, I had this thought in mind. Okay, V1 bar minus V2 bar equal to null vector, because we subtracted the and two non-zero or two unequal vectors, right? V1 bar and V2 bar will have a non-zero subtraction, and then its cross product with any other vector will be a null vector only when they are collinear. Okay, so T is correct. But her approach is also right. She's saying if three vectors are coplanar, okay, we can always write their linear combination for 0. So it's a 1 V1 bar plus negative 1 V2 bar plus negative lambda A bar is equal to 0. There is a theorem, okay, which says that if three vectors are coplanar, then there exist three non-zero scalars, or three scalars, at least one of them non-zero, such that that scalar into first vector but plus some other scalar into some other vector plus some other scalar into some other vector is equal to 0. Okay, so and because we have proved that already A bar, V1 bar and V2 bar are coplanar, we will have that particular condition. Okay, so option D is correct, option C is correct, option B is correct, option A is not. Any doubt in this question? Yes.
Can you explain the last option once again?
Which method? The one on the left or the one on the right?
You could do both.
See, this is given, correct? Yes?
Yeah.
Just subtract and use the
Okay.
हाँ,
Uh-huh.
ये clear है ना?
Yeah.
नीचे
Yeah.
okay. Now for this the condition of coplanarity of three vectors, we can always think of the third vector as being expressed as a linear combination of the other two. That's what I used here. यहाँ पे जो बताया वही है वो. Okay, if you open NCERT you will find the theorem which says that if we have three coplanar vectors, then you can always find non-zero solution here. Okay, by which if we multiply the three vectors we will get 0 1. But see, this there is no need to prove this because it's known that they are coplanar. It's known that they are coplanar, so we can easily arrive at that particular conclusion. Clear?
Okay, yeah.
So first method is more, I would say, like solving a problem based. The other one is basically just invoking the theorem and arriving at the conclusion. Okay. Now let's take this question. Slightly tricky or difficult, I would say. Second one from vectors. This question is from a NEST 2022 second shift, and well, when I looked at it for the first time, I thought of using this particular identity, which says a bar cross b bar cross c bar is a bar dot c bar b bar minus a bar dot b bar c bar. Okay, especially when you look at option B. Okay, when you look at option B, we are required to use that. Okay. Let p bar, q bar and r bar be three non-zero vectors in three-dimensional right-handed rectangular coordinate system. That means IJK. Then option A, if p bar, q bar and p bar plus q bar are unit vectors, then magnitude of p bar minus q bar is root 3 by 2. Okay, so what can we say about them? Well, we can prove this in multiple ways. One way is to actually solve it. Okay, so let's go for it now. Okay, so what is magnitude of p bar minus q bar? Okay, let's take the dot product of this with itself. Let us take the dot product of this with itself. So this will give us the square of the magnitude. Okay, so this will be magnitude of p bar squared. Okay, minus, plus magnitude of q bar squared minus 2 p bar dot q bar. Is that clear? 1 plus 1 is 2. बोला है यूनिट है तो 2 ले सकते हैं यहाँ पे. So it will be 2 minus 2 times p bar dot q bar. ठीक है. Now let's make use of the fact that p bar plus q bar is also a unit vector. So what will be p bar plus q bar dot p bar plus q bar? We know it will be 1 because its magnitude is 1. Okay, but on the right side it will be mod p bar squared plus mod q bar squared plus 2 times p bar dot q bar, and here we are using the commutative property of dot product. Even in the first case we use that p dot q is q dot p. Okay, so this will be 2 plus 2 p bar dot q bar. Now, do you realize that p bar dot q bar is minus 1? Sorry, 2 p bar dot q bar minus 1. Just send 2 here, so it will give 1 minus 1 negative 1 and send okay, don't send 2 anywhere because we want this expression only. Okay, we want this expression only, and what is that? 2 p bar dot q bar, that's minus 1. Okay, so I can say magnitude of p bar minus q bar squared will be 2 minus negative 1, 2 plus 1 is 3. Therefore, magnitude of p bar minus q bar will be root 3. Does it match with root 3 by 2? Doesn't. So option is not. Is that clear?
Yes, sir.
Okay. Fine. Now, can you suggest me any other method for this? Yes.
Yes, I was going to say we can also use geometry
And
by
what would?
considering an equilateral triangle with the sides p vector, q vector, and p plus q vector.
Yeah, okay, great. So she is saying equilateral triangle. Okay, so you're saying this is P, this is Q, and this will be P plus Q. Yeah, ये भी possible है, कर सकते हैं. What I had thought of was, mm, yeah, I think my approach will not work anymore because I was planning to take P bar as I cap. Okay, but I want Q bar also a unit vector and P bar plus Q bar also a unit vector. Yeah, we can do it. Let's say we take this as I cap. We are required to take a unit vector in this direction and a unit vector in this direction, so that if we draw a circle, then all the three vectors as edges, they lie on the same circle. Okay, we can do it. Yeah, Anaga, please continue. How would you solve the problem after taking that as equilateral?
So we can see the P vector plus Q vector. So for P vector minus Q vector, we will have to draw another vector, which is basically the negative of Q vector.
Correct.
And since it is an equilateral triangle, the angle between two sides would be 60 degrees. So the angle between the new vector that we have drawn and P vector will be 120 degrees. From here we can solve and see that the value of P vector plus the negative of Q vector is not root 3 by 2.
Okay, correct. Has everybody understood what she said? She said if P bar, Q bar and P bar plus Q bar are all three unit vectors, and if we use triangle law to add P and Q, then obviously we will get an equilateral triangle because all three vectors will have same magnitude. Then she is saying rotate Q by 180 degrees to get minus Q, and then find the magnitude of P bar plus minus Q bar. Yes, Anaga, you can do it. Alright, now let's go to B. Okay, what does B say? B says that the vectors P bar cross Q bar cross R bar, Q bar cross R bar cross P bar, and R bar cross P bar plus cross Q bar are coplanar. Okay, they are coplanar, and we have to use, if we use this identity, then our job will become easier to draw conclusions, because for cross products it's a bit tedious. Okay, so let's do that now. Okay, let's do that. What would be the expression for this? Yes, what will be the expression for this? P dot RQ minus P dot QR. ठीक है? Then Q bar dot R bar cross, sorry, Q bar cross R bar cross P bar. This would be what? ACB. So Q dot P, now let me write it as P dot Q only because it's commutative. P dot Q R minus Q dot R P. And what can be said about the third one? P dot Q, R dot Q P, R dot Q P minus P dot R Q. Okay, so how can we conclude that they are coplanar? Do you see anything? यस मुझे भी वही लग रहा है. Like if I add this vector and this, okay, 0 आ रहा है क्या?
Sir, I don't think so because any vector is added once or subtracted twice or vice versa.
Yeah. So that's what I said. Let's say this is we add 1 and 2. Okay. If we add 1 and 2, p dot rq is getting cancelled. So we are getting r dot qp minus p dot qr. Is this negative of q bar cross r bar cross p bar? Yes, let us confirm it once. ये नेगेटिव क्यू आर पी है, ये पॉजिटिव क्यू आर पी है, ये पॉजिटिव पी डॉट क्यू आर है, ये नेगेटिव पी डॉट क्यू आर. Yes, so indeed when two vectors are added we are getting negative of the third vector, but that essentially means the three vectors are coplanar. Okay, therefore, okay, now let's call these vectors as a bar, b bar and c bar. We can say that b bar is actually negative a bar plus negative c bar. Oh, sorry, not that, sorry. Negative b bar is equal to a bar. Yeah, okay. उनका ये एडिशन भी 0 आ रहा है. Yes. Yeah, Roshan, if you said that let us add three vectors, their addition is getting is 0 null vector, then also you can say that they are coplanar. ठीक है? Because see if we are getting cancelled vectors PRQ minus PQR plus PQR minus QRB. Yes, okay, वो भी आ रहा है. ठीक है, great. So it was based on this identity and option B is correct. Let us go to C now. Okay, let's go to C now and then finally we'll go to D. Okay, option C. If P cross Q is R and Q cross R is P, then P, Q, R are orthogonal in pairs and mod P is equal to mod R. Orthogonal means perpendicular. In linear algebra, when we extend the notion of dot product to higher dimensional vectors, then it's not possible to visualize them. So we use this word orthogonal instead of saying perpendicular. Okay? Okay. P cross Q is R. And Q cross R is P. What can be done? Use this R here. Okay, use this R here to see if we get anything. So Q bar cross P bar cross Q bar is equal to P. Okay. Now what can be done? We can again use that identity. Which identity? A bar cross B bar cross C bar is equal to ACB or A dot CB minus A dot BC. Okay. So what are we going to get then? Q bar cross P bar cross Q bar, it would be mod Q bar squared P bar minus P bar dot Q bar Q bar. This is equal to P bar. Okay. Now what can be said about the equality? See, look, Q bar cannot be null vector because otherwise LHS will become 0 and RHS is not 0. Okay? Therefore P bar dot Q bar must be 0, implying P bar is orthogonal to Q bar. Additionally, we can also conclude that magnitude of Q bar squared is 1 So q bar is unit. यहाँ से mod q bar squared p bar is equal to p bar. Is this part clear? Like in option B, option C also, in option C also we have used this identity. Okay, we have used this identity here, and we have arrived at the conclusions that p bar is perpendicular to q bar. Okay, p bar is perpendicular to q bar, and secondly, magnitude of q bar is 1. Okay, although there is no mention of that in the options, we have arrived at that as an additional result. Okay, now look here, combining magnitude of p bar, combining p bar perpendicular to q bar, combining p bar perpendicular to q bar with this. Okay, let's say I call this as C1, and let's say I call this as C2. So from C1 and C2, what can I write? I can say p bar perpendicular to r bar, q bar perpendicular to r bar, p bar is also perpendicular to q bar. मतलब mutually orthogonal हो गया. So this part is proved, but it's and. मतलब दूसरा भी check करना चाहिए. If the second one doesn't turn out to be right, option C will be incorrect. Otherwise, it will be correct. So how to prove that? How to prove that? Having proved that all of them are orthogonal, okay, having proved that all of them are orthogonal, what can be said about this? Magnitude of P into magnitude of Q is equal to magnitude of R. Magnitude of Q into magnitude of R is equal to magnitude of P. I think now we can make use of the fact that Q bar is a unit vector. Let's call it C3. From C3, magnitude of P bar equals magnitude of R. Is that clear, or shall I explain it again? Clear or no?
Yes.
Yes.
समझा ना क्या किया पहले? First of all, we use this identity to arrive at two conclusions, which are C2 and C3. We first combine C1 and C2 to arrive at a conclusion that the cross products are mutually perpendicular orthogonal, or the vectors. And because q bar was a unit vector, its magnitude was equal, so that question did not arise. Okay, fine. So C is correct. How about D? If P, Q, R are unit vectors and the angle between P bar plus Q bar plus R bar and any of P bar, Q bar and R bar is same. I don't think that is true, and we can easily prove it, or disprove it rather, by considering a counter example. Look here. Suppose P bar is I cap. Suppose Q bar is J cap. And let us suppose R bar is I cap plus J cap upon root 2. Note that all three of them are unit. है ना? Magnitude of R bar is also 1. ठीक है? Now when I add P bar, Q bar and R bar, I am bound to get a vector along the line y equal to x, which clearly means that adding these three vectors is giving us a vector collinear with R bar, but making angles of 45 degrees with P bar and Q bar. So can option D be correct? No. We cleverly chose an example in such a way that all the requirements in the problem were met, but the conclusion is not in agreement with what the option is telling us. Okay, it has said any, so one counter example is enough. Any doubt? Yes.
No, sir.
थोड़ा मुश्किल है. मुश्किल in the sense you need to correctly arrive at that result. Okay. If you choose a step which is not taking you to the solution, it will take some of your time. ठीक है. I also initially tried to do it this way. So I assumed that angle is theta p, but then it took me a lot of time. Okay. P बार डॉट पी बार तो वो 1 आएगा, फिर P बार डॉट क्यू बार, फिर P बार डॉट आर बार, तो वो cos थीटा 1 प्लस थीटा 2 ऐसे बहुत सारे हो जाता है वो. ठीक है. सो इट्स बेटर टू look for a counter example and luckily we got this counter example. ठीक है. Okay. So option D is correct. Okay, one final time I'm asking, is there any doubt in question 2? Because we have been using dot cross a lot, also the vector triple product. If you have, please tell me. Otherwise, we will go to the next question.
So could you give a quick summary of what we did in this question?
Okay, see, basically in this question, the given part was a general statement that we have 3 non-zero vectors. Okay, and then each option was an independent question in itself. Okay, independent question in itself, because in option A they said PQ P plus Q unit vectors, but for B they haven't mentioned that. So if PQ and P equal plus Q are unit vectors, then we began thinking in that way, and the most common property that we use for finding the magnitudes is using the dot product. है ना? And the other thing is that if we take dot product of any vector with itself, we will get the square of its magnitude. Clear? We used that property in A. Any doubt there? No?
No, no.
Okay. And also commutativity of dot product was used. हाँ बोलो.
What's the use of this three-dimensional right-handed rectangular coordinate system? It's used in any?
इसका मतलब क्या है? इसका मतलब I क्रॉस J अगर लिया ना, तो K का जो डायरेक्शन आता है वो राइट हैंडेड स्क्रू रूल से आता है. गॉट इट? एक्चुअली वो जो 3D राइट हैंडेड सिस्टम है उसको रिप्रेजेंट करने के लिए लेफ्ट हैंड ही लगता है, आई जे के. बट when we say right handed rectangular, it means right handed curled fingers rule. If you rotate your fingers from I to J, thumb will point the direction of K. ठीक है. अच्छा, in options B and C we used this identity. और नेक्स्ट में और भी एक ऐसा इंसिडेंस है जहाँ पे उन्होंने इस आइडेंटिटी पे क्वेश्चन पूछा है, तो ये करके जाना. ए बार क्रॉस ब्रैकेट बी बार क्रॉस सी बार इज ए डॉट सी बी माइनस सी डॉट बी सी. ठीक है. बी बीच में माइनस साइन है, याद रखना. ओके.
That's a vector triple product, right?
Yes, that's a vector triple product. And for option D, well, I couldn't figure out any other way apart from the counter example that came to my mind, that if you take P and Q as R, Ij, and R bar as I plus J by root 2, then, well, the angle is not the same. ठीक है. Okay, fine. So that's with this question. Basically it has made use of everything that we know about vectors except perhaps scalar triple product. ठीक है. Okay. Question 3. Now I thought of giving this problem to you as classwork problem. This is also a multiple select question from NEST 21, but is it okay if I give this to you as homework, because we are running out of time? The question is simple. Let I, J, K be 3 mutually orthogonal unit vectors. Let x bar be I plus J, y bar be J plus K, z bar be K plus I. And we just have to well, look for all the options, because we know their representations. I, J है, J, K है, K, I है. Option A mutually orthogonal. B x plus y plus z is 2 times x cross y plus y cross z plus z cross x. x dot x plus y dot y plus z dot z equal to 2x dot y dot plus y dot z dot x z dot x dot vectors x y z are not coplanar. आएगा ना, ये आसान है.
Yes, sir. Please.
Okay, I'm leaving this to you. Okay, this is also a very nice MCQ, MSQ. Okay, if we go by the standard method, is only one result is obtained. Unless you know that it is a multiple select question, you will end up happily marking that option and proceed. But actually, it has other options right also. Okay, let's see this question. This is from Nest 16, question 12. Let A bar and B bar be two non-collinear vectors. बोल दिया है नॉन कोलिनियर है, मतलब जीरो भी नहीं है वो, है ना. एंड मैग्नीट्यूड ऑफ ए बार इज इक्वल टू मैग्नीट्यूड ऑफ ए बार इज इक्वल टू 1, मतलब यूनिट वेक्टर्स है. इफ यू बार इज ए बार माइनस ए बार डॉट बी बार, देन रूट ऑफ यू बार डॉट ए बार इज ऑप्शन ए मॉड ए बार क्रॉस बी बार, ऑप्शन बी मॉड यू बार, ऑप्शन सी मॉड यू बार क्रॉस ए बार, ऑप्शन डी मॉड यू बार क्रॉस बी. ओके, तो कैसे निकालेंगे? let's start with u bar dot a bar. Okay, let us start with u bar dot a bar. ठीक है, what would it be? a bar minus a bar dot b bar dot a bar. Is that clear? We haven't done anything. Okay, what we have done is we have made use of this expression for u bar here. Okay, ये जो दिया था वो यहाँ पे डालो. ठीक है, now use a dot product algebra. a bar dot a bar, magnitude of a bar square minus a bar dot b bar dot a bar. So this will basically be what? a bar dot b bar ka square, because again I told you same vector when multiplied to itself dot product we will get magnitude squared. ठीक है, so mod a bar squared minus mod a bar squared mod b bar squared cos squared theta. But because both these vectors are unit vectors, we will get 1 minus cos squared theta or sin squared theta. Is that clear?
Yes, sir.
Therefore, root of u dot a is sin theta. Part 1, part 2. अब देखो part 2 में let's start with option A. What is magnitude of a bar cross b bar? Magnitude of a bar, हाँ, correct. So if you think that only option A is correct, okay, unless you know that, well, of course that possibility doesn't exist anymore for Nest now, at least in this year, for this year, because no MSQs. But it's interesting to see that B and D also give us the same result. Okay, how? Let's go for magnitude of u bar now. Okay, let's go for magnitude of u bar now. ठीक है, magnitude of u bar कैसे निकालेंगे? magnitude of u bar, I've told you always use dot product for that. ठीक है, तो सबसे पहले उसका स्क्वायर निकालेंगे. Okay, the square of this vector would be okay this thing dot multiplied with the same thing. ठीक है, this thing dot multiplied with the same thing. Okay, let's start. A dot A. अच्छा, so is it okay if I write 1 there? क्योंकि वो a bar b bar unit vectors ही है, चलेगा? A bar dot a bar 1 minus a bar dot b bar into a bar dot b bar, so square, minus a bar dot b bar ए बी बार डॉट ए बार डॉट प्रोडक्ट कम्यूटेटिव, तो अगेन ये हो गया प्लस ए बार डॉट बी बार squared into b bar dot b bar, which is again 1. Okay, so effectively what are we getting? 1 minus a bar dot b bar square. ये दोनों cancel हो जाएंगे. Now please understand how the fourth term turned out. See, look, negative, negative, positive, है ना? फिर b bar dot b bar is 1 like a bar dot a bar because it's a unit vector and a bar dot b bar is already there. ठीक है? So this is 1 minus again cos squared theta now. तो ये sin squared theta हो गया. तो mod u bar कितना हो गया? sin theta. So p is also. Okay, b is also. What can you say about c and d? Okay, what can you say about C and D? देखेंगे, है ना? Do it together. Okay, so let us first consider u bar cross a bar, which will be a bar minus a bar dot b bar cross a bar. Now a bar cross a bar is null vector minus a bar dot b bar cross a bar. So this will be a dot b a cross b. Okay, so the magnitude will be what? Magnitude will be root of mod of cos theta into sin theta. Okay, fine. So that's not equal to sin theta. Okay, that's not equal to sin theta. Now how about b? Okay, how about b? Okay, this vector again cross b bar. Okay, this vector again cross b bar. So this time it is a bar cross b bar minus null vector because of b bar cross b bar. So got it. Magnitude of u bar cross b bar is equal to sin theta. तो हो गया वो. Okay, so wherever we are getting sin theta, you should mark it, otherwise you will not. So a is right, then b is right, c is not right, d is right. Okay, understood?
Yes.
Yeah. Okay. Fine. So those were the problems that I planned to take today from vectors. I know we are running out of time, and well, the good news is that from nest PYQs at least, very few of them are from 3D coordinate geometry. Okay, and the ones that are there, we have already solved them. So for students who were not here for our IISc aptitude test sessions, I will share the solutions with you. Okay, you please go through those nest PYQs, and I'll show you the questions that I have planned for today on 3D geometry. Okay, so for the 3D geometry, I picked 3 questions from JEE Advanced 2024. Okay, so this is question number 11 from that. Okay, let p bar be 2i plus j plus 3k and q bar be I minus j plus k if for some real numbers alpha beta gamma we have 15i plus 10j plus 6k equals alpha into 2p plus q plus beta into p minus 2q plus gamma into p cross q, then the value of gamma is. आएगा क्या ये? I don't see anything difficult here. ये आ जाएगा, ये आ जाएगा, क्रॉस प्रोडक्ट आएगा, उसके बाद सिस्टम ऑफ लीनियर इक्वेशंस मिलेगा. Okay, you will get system of linear equations in alpha, beta and gamma. Okay, so question 11 is done. ये ट्राई करो, अगर नहीं आया तो मैं इसका सॉल्यूशन आपको भेज दूंगा. हैव यू गाइस स्टडीड प्लेन?
Yes, sir.
Yes, sir, but I don't think that's in the syllabus for next.
नेक्स्ट में नहीं है क्या?
Sir, NCERT syllabus है ना next.
वो आयसर वालों ने भी बोला था, लेकिन उसने जो PDF था उसमें बोला था प्लेन से. ठीक है.
So the PDF in the next thing redirects to the NCERT syllabus.
ओह या करेक्ट. ठीक है, देन यू कैन स्किप दिस. ओके, इसमें फिर प्लेन ही है. ठीक है, आई ट्राई टू आई रिप्लेस दीज क्वेश्चंस बाय सम 3D लाइन्स ओनली क्वेश्चंस. ठीक है, कूल. सो दैट्स इट फ्रॉम माई साइड फॉर टुडे. Our next class will be tomorrow because this was supposed to happen yesterday. And what is tomorrow's topic? Electromagnetism. Let me check. One sec. Yes, tomorrow's topic is electromagnetism. तो उसका थोड़ा रिवीजन करके आओ. कल हम नेक्स्ट PYQs ही लेंगे, तो उसमें everything will come. AC circuits, electromagnetic induction, magnetic effects of electric current, magnetism, electrostatics. Yes, on current electricity. Yes.
So can you also provide mock tests for next, like you did for IIT? Because none of the previous year papers are based on this pattern, so we don't have anything at all to practice from for the IIT.
No, but as far as questions are concerned, the level will be the same. The only thing is they will not be multiple select questions. Right. I'll try my best to come up with next level mock tests, but I don't think I have enough time to do that. I mean, if I give you random questions, you'll say and thinking you will think ये उसी level के है, और अगर नहीं आए तो ये होगा. तो basically I don't have that much time right now because my 11th and 12th regular batches have also started. So I cannot promise, but I'll try my best. Otherwise, I have already shared the PDFs with you of next PYQs. You please go through them. Okay.
Okay, sir.
Yeah. All right. See you tomorrow for physics at 7 o'clock. Please revise electromagnetism. And I'll replace these plane level questions with something else. Take care.